All right, ladies and gentlemen, today we're taking a look at notes 3.1. Notes 3.1, and we're doing negative and zero exponents. So the first thing I want to do is make sure you understand this vocabulary of base and exponent. So this would be our base, and the small number would be our exponent. So if I said 2 to the third power, our base is 2, and the exponent is 3. If I said x to the fifth power, our base is x, our exponent is 5. The exponent is always that number that's raised to the superscript and is a little bit smaller. Now, one of the things that can happen is we can have a negative exponent. Now I want to make sure that you point to your formula card and you find this rule that's written on there. It's underneath the tab that says property of exponents. And what this rule says is it says if you have a negative exponent that you're going to change its location. So if I have a negative exponent in the denominator, then I'm going to change the location to the numerator. Whereas if I have one in the numerator, then I'm going to change it to the denominator. So let's take a look at problem number 1. So this says I have 6 to the negative 4. The base is 6. The exponent is negative 4. If I have a negative exponent, it says to change its location. So I'm going to move it to the denominator, and I have 6 to the 4th. But I have to put it over 1. Now, I don't know how to do this part in my head. So in my calculator, I would say 6 caret 4, which gives me 1,296. The mistake most kids make is they'll just write down 1,296, and that's not what you want to do. You want to put it over 1. Because our original part was over 1. Taking a look at problem number 2. Problem number 2 is a little tricky. Because of the parentheses, this negative 4 is our base, meaning it's all raised to the negative 2. So I have a negative 2 exponent. That negative exponent tells me I need to change its location. It's in the numerator right now, so I'm going to take it and drop it to the denominator. Notice that when I drop it to the denominator, the exponent is no longer negative. I kind of think of it as a TV show where a little kid is pestering his mom and going, Mom, 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 Mom. That's what this negative 2 is doing, only what it's doing is it's saying, move me, 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 move me. And so then I have to take it and move it so it'll shut up. So finally, it's shut up. I take this and put it in my calculator. I have to put the parentheses around it. Then I would press caret 2, and I get out 8. So now I know my answer is 1/8. Now take a look at number 3. Number 3, I have 2 annoying kids. This one is saying, move me, move me, move me, move me. And this one is saying, move me, move me, move me, move me, right? So if this is in the numerator, in order to make the exponent positive, I've got to move it down. And if this is in the denominator, I need to move that one up. Now I can't necessarily do 3 cubed in my head. That's what this is, 2 raised to the 3 power. So I would say 2 caret 3, and I get out 8. And there's nothing I can do with the variable in the denominator, so I'm finished. Taking a look at problem number 4. Now number 4 we already have filled in for you, so just stop and listen on this one. So this one has a negative exponent. That means this one is saying, move me, move me, move me, move me. Does the 11 have a negative exponent? Yes or no? Say it out loud. You're right. No, it does not. So it's going to stay in the numerator. Now this one said, move me, move me, move me, move me. So I'm going to move it down to the denominator. And that's it. Okay, so just to make sure we're recapping negative exponents, if you have a negative exponent, it means to change the location. If it's in the denominator, you move it to the numerator. If it's in the numerator, you move it to the denominator. And notice that the exponent changes signs once you move it. It becomes positive. It's happy once you've given it what it wants. Now we need to move on to zero exponents. You should be looking at your blue formula chart and pointing to this rule on your blue formula chart. Now, I know it seems stupid for us to make you point, but we know if kids point to the formula chart that it makes a difference in their success level. So I want you to take the time to find that formula chart and point to it. Now, what this rule is saying is it says if I have any base raised to the 0 power, that it equals 1. So if I said 3 raised to the 0 power, it equals 1. If I said 30 raised to the 0 power, it equals 1. So what is 10,000 raised to the 0 power equal? Why don't you tell me on 3, 2, 1. Yeah, you're right, it's 1. Now I'm just going to write down a bunch of stuff. Raised to the 0 power, what does it equal? On 3, 2, 1. Yeah, it's 1. So this rule is super easy, right? So here I have my base of 1/4, and it's raised to the 0 power, so I know that equals 1. Pardon me. Taking a look at problem number 6. Now, I can't tell if this is a decimal or a comma in my notes. I think it's a decimal. But if I have 34.968 raised to the 0 power, what does it equal? 1. Yep, you're right on that. Now, this one's going to get a little tricky. I'm going to rewrite it just so that you can see my thinking. I'm going to deal with this number by number, letter by letter, but I want to deal with my 0 and negatives first. So when I look at z to the 0, I know that anything raised to the 0 is 1. So I can pretty much just ignore that, only it didn't erase that for some reason, so that's a little weird. Not really sure why. And so then all I have to deal with now, yeah, it still won't erase it. Isn't that funny? All I have to deal with now is I just have to look at what's left, which is this part of the problem. And so I go through and I ask myself, do I have any negative exponents? Yeah, the answer is right here. Okay? What's happened? So the -4 is negative, but it doesn't have a negative exponent. A negative exponent would be here. So the -4 is going to stay in the numerator. The x to the -3 is saying, move me, move me, move me, move me. So I'm going to move it to the denominator. When I move it to the denominator, the exponent becomes positive. And then I have y. And I'm going to leave y in the numerator because it doesn't need to move. It's not upset. And so now we're finished. Now some of my students like to write it where they leave the exponent of 1 on the y value and they write that ninja 1 right there. That's fine if that's what you need to do. There's nothing wrong with that. Now let's take a look at problem number 8. Now I want you to look at problem number 8 for just a minute and ask yourself, is there anything raised to the 0 power? I want you to look for the negative exponents and the 0 exponents first. So I notice that this entire thing is raised to the 0. That means it's going to equal 1. And I can mark it out because it's going to just divide out to, or just equal 1, and anything multiplied by 1 is the same, so I don't have to worry about it. Now I'm going to take a look at number 8. Looking at it number by number, letter by letter, I notice that this one has a negative exponent, this one has a positive, and that one's just fine. So I know that 4 is going to stay in the numerator. I know m squared is going to stay in the numerator, but n has to move, and it's going to go to the denominator, and it's n squared. And now it's happy. That's it. There's nothing tricky about these problems. Talk about what we did in this lesson. So in this lesson, we talked about negative exponents. If I have a negative exponent, that means it's going to change locations. So if I had 4x to the -3, that means this x to the 3rd is going to go to the denominator. But then what happens if, and I'm just making up these problems, okay? What happens if the negative exponent is in the denominator? Well, all you're going to do is change the location. It's 3x to the 4th, y to the 3rd. Again, that negative exponent is saying move me, move me, move me, move me. So the first thing we did was we talked about negative exponents and how they mean to change the position. The next thing we're going to talk about, the next thing we talked about was 0. And we know that anything raised to the 0 power equals 1. So if I had 2 to the 0, it equals 1. If I have this base and I raise it to 0, it equals 1. And finally, we talked about the product power to power rule, or the product of power rule. This rule says that if I have the same base and they're multiplied, that all I do is add the exponents. So what that means, if I had 3 squared times 3 to the 5th, then that would be 3 to the 2 plus 5, which is 3 to the 7th. And that's all that rule has. So we basically looked at 3 exponent rules. So I have no idea what. Before I finish, I want to make sure that we. Surely that's not it for the notes. Aha. Good. All right, now, problem number 9. I want to talk to you about the language and a way to help you remember the language. So, all right, so taking a look at problem number 9. The directions we have on problem number 9 are expand it and then simplify. So I'm going to take it and expand it. So notice I have x to the third power, t to the third power and t to the fourth power. So t to the third power I have 1, 2, 3 t's. T to the fourth power of 1, 2, 3, 4 t's. I wonder what rule they're trying to get me to see. I have t to the third power and t to the fourth power, which gives me t to the 7th because I have 1, 2, 3, 4, 5, 6, 7 t's. I wonder if there is a connection between those exponents. Now, if you're seeing that connection, don't yell it out. Let's take a look at number 10. Now, I'm going to expand and simplify. If I were to tell you that my grandmother cooked me Thanksgiving dinner and my stomach expanded, would you think I was thinner or bigger? Okay, so we're making these bigger. And I'll tell you what, if my grandmother were cooking, I would eat the heck out of that. Okay? So, I'm going to take a look at it number by number, letter by letter. I'm going to rearrange it first. So I put all of my numbers together, and then I put all of my same letters together, or the same bases together. So r squared and r to the 6th. Now the first thing we're doing is we're getting you to expand it. Now with the numbers, we're not going to worry about expanding it. What is 5 times 6? You're correct, that's 30. But with the letters, I'm going to expand it. So r squared is r times r to the 6th is 1, 2, 3, 4, 5, 6 of them. So again, number by number, letter by letter, I've expanded. Now I'm going to simplify. I have 30. How many r's do I have? 1, 2, 3, 4, 5, 6, 7, 8. R to the 8th. Wonder what pattern they're trying to get us to see. I have r squared and r to the 6th, which gives me r to the 8th. Are you seeing the pattern yet? Well, if you're not, it's time to turn and look at your blue formula sheet, and you're looking for product of powers. And when you look on there, I want you to literally point to this formula right there. So this formula says whenever I see the same bases, that I'm going to add the exponent. Now let's look up here again and look at this problem. So I had r squared times r to the 6th. The bases are the same. They're both r. And what I did was I said 2 plus 6, which gives me r to the 8th. So that's all that this is saying. It's saying if you have the same bases, you simply add the exponents. That's it. That's all that rule is saying. Now it's important that you point to that rule so that you get used to it. Now let's take a look at problem number 11. Now most of it is written in for you, so you shouldn't have to write, and you should be able to just listen. So I know that if I have a to the m times a to the n, that equals a to the m plus n. In other words, I have the base of 2, so I keep the base the same, and I'm going to add the exponents, and it's going to be 3 plus 5. Well, I know that 3 plus 5 is 8, so I end up with 2 to the 8th power. Now, I need to plug that in my calculator. So if I'm going to plug this in my calculator, I would say 2 caret 8. And when I do that, I'm going to get 256. And we're done. Taking a look at problem number 12. Now I want you to notice how we've organized it, and we've used colors to kind of help you see it. But if you look, I took numbers and then I took letters and I put them together. So you're going to hear me say number by number, letter by letter. And you can even kind of think of it as a column and do all your number work on one side and all your letter or your variable work on the next side. So what is 2 times 2? That's 4. This would be the same as v to the 5th plus 4 because the bases are the same. So I know it's 4v to the 9th. Now that line or that column is only there to help keep me organized. This is my final answer. Follow, follow. Oh wait, this is a recording. You guys don't know that. Never mind. Taking a look at number 13. Again, number by number, letter by letter. So I'm looking at, oh, it marked it out. That's no good. Let me try this again. I'm looking at the letters or the numbers first. There they are. Then I'm going to do all of my x's. Oh, that's the only x I have. And then I'm going to do all of my y's, and I'm going to put all my y's together. So number by number, letter by letter is what you're going to hear me say. So 14 times 2, that's 28. You know what? I'm going to use color on this, so give me just a minute. 14 times 2 is 28. Do I have any exponents I can add? No, that's the same base. And then if you take a look at here, this is the same as y to the 4 plus 3. So what happens is I end up with 28 x squared. 4 plus 3 is going to be y to the 7th. And now we're finished with our problem. Now I used color in this case to kind of help you see how we're working it all the way down. I just wanted you to see that. For some of you, drawing a column is going to be helpful. That's okay too. It's up to you on what you want to do. Number 14. Boy, that looks like a pain, doesn't it? Oh, all right. So I know when I have 2 parentheses side by side, that means they're multiplying. Now I'm going to highlight these in different colors so you can see how I'm doing this. And so you can see what my eye is seeing. All right. So I'm going to do it number by number, letter by letter. So I'm going to put all the numbers together. I'm going to put all the same bases together. Now, 5 times 3 is going to be 15. Is there anything else I can do to that column? No, so I'm finished. So again, number by number, letter by letter. Now I'm taking a look at the a's. They have the same base. So this is the same as a to the negative 3 plus 2. All I'm doing is adding those exponents, which that's a to the negative 1. I'm writing that 15 down so I don't lose it. When I take a look at the next one, that's b to the negative 1. Now there's not an exponent written there, but it would be plus 1, which would be b to the 0. So again, rewriting things just so I can keep track of it. B to the 0 goes to 1. This one is saying move me, move me, move me, move me, and I move it to the denominator. And now we're finished. Again, I want to go back through that again to make sure you're following me and you're with me on it. First thing I did was I organized it number by number, letter by letter, meaning I put all the numbers together and the same bases together. Then I kind of think of this as a column where I just work it. So 5 times 3 is 15. I could drag it all the way down to my answer if I wanted to, but I tend to rewrite it every time. Letter by letter means I'm going to start by taking a look at the A's. I see that I have the same base, which means I can add these exponents. Negative 3 plus 2 is negative 1. Then I look at the B's. b to the negative 1 plus 1. b to the negative 1 plus 1 is 0. Anything to the 0 is 1. It is now gone. I notice this a has a negative exponent. It says move me, which means I change the location. And there I have my answer. Now let's take a look at 15. It says find the area of the square. So I know an area of the square is a equals L times W. Wait, it said find the area in square units of a rectangle. I know the area of a rectangle is a equals L times W. It says it has a width of 2x squared y squared and a length of 4x to the 5th y to the 1/3. So that means that the area equals 4x to the 5th y to the 1/3 times the width, which is 2x squared y squared. Now again, we're looking at this number by number, letter by letter. Now I'm going to write over those in different colors so that you can see how I'm doing that. So number by number, letter by letter. I'm going to put my 4 and 2 together. I'm going to put the same bases together, or letter by letter. So I've got x to the 5th and x squared. And then I'm going to put my y to the 1/3 and y squared together. Do you understand how I'm reorganizing it? I'm putting all the numbers in the same place, all the same letters in the same place. So I've got all my whole numbers or my integers, then I have my x's with a base of x and my y's with a base of y. So I'm going to rewrite. 4 times 2 is 8. When I take a look at this, it's x to the 5 plus 2. And this becomes y to the 1/3 plus 2. Now I'm showing every single step. Some of you will go from this step to this step, and that will be just fine. So it'd be 8. X to the 5 plus 2 is 7. And then in this case, if my fraction skills aren't acceptable, then I would use my calculator. I would say alpha y equals, type in 1/3 plus 2, and have it give me the answer. And that would be y to the 7/3. And that's my answer. I have 8x to the 7th, y to the 7/3. The big thing to remember on these problems is number by number, letter by letter. You need to remember number by number, letter by letter. In other words, you're organizing it in a way where the numbers are together and each of the same bases together, or each letter. Now that's it for notes 3-1. All right. If you get stuck on your homework, you can go back and watch this notes, but you should be working assignment 1-3 and getting that started and done and ready to turn in. Thank you for watching the videos. Have a good day. Together.